Hello, everyone. Thanks for joining us for our next live session. I'll be your producer for our session, but before we start, I do have some quick housekeeping. Please take a moment to read our code of conduct. We seek to provide a respectful environment for both our audience and presenters. While we absolutely encourage engagement in the chat, we ask that you please be mindful of your commentary, remain professional and on topic. Keep an eye on that chat. We'll be dropping helpful links and checking for questions for our presenters to answer. Our session is being recorded. It will be available to view on demand right here on the Microsoft Reactor channel. With that, I'll turn it over to our speaker for today. Thanks for joining us.
Hey, everybody. I'm back. Paul Yu here from the Cloud Native Developer Advocacy team. And we are here for our final episode in the series that we've been doing, basically doing AKS Labs on the Microsoft Reactor channel. We're actually streaming on two different channels, on the Microsoft Reactor channel, as well as the AKS community YouTube channel. So we're in both places. You can always come back and catch a recording here. We've been doing this stream for a few months now. I think we've been doing this since May, where we just dive in and do AKS hands-on labs, and we kind of walk you through it. This is the final episode, but I am excited to bring you this one because this is a brand new lab that we just published recently. And so today, we're going to dive into the AI space and show you how Kubernetes makes AI, and in this particular case, makes retrieval augmented generation just a little bit easier with the KAITO project. Okay. And so in this session today, we're going to be deploying an AKS cluster. We're going to install KAITO, and we're going to start playing around with the RAG engine component so that we can, it'll basically give us like a launching point to build out these RAG enabled applications, and it's going to be super easy. So happy to be here today. I'm happy you folks have joined for the last session. Feel free to comment in the chat box there. Let us know where you're from. Let us know how you've been enjoying the series so far. And let us know if you've actually heard of the KAITO project. Okay. If not, no worries. We're actually going to dive into it right now. And so I don't like slides particularly. I just have it up just so that we have some sort of like reference point. But this is all we're going to do here. We're just going to dive into the workshop. These are the two URLs that you're going to, well, you only need one URL, but I have a backup URL just in case. So go ahead and navigate to this URL. This is the short URL. So if you go to aka.ms/AKS/labs, you'll be taken to the AKS Labs workshop site. I do know sometimes, depending on where you are in the world, that short link doesn't always work. So here's the full URL if you need it. Okay. So this is a workshop repo that's actually hosted on GitHub pages. And so you can access it at azure-samples.github.io/AKS Labs. And so that's where it will take you. Okay. So we have a lot of folks in the chat here. Welcome. I see things are scrolling by a little too fast for me, but greetings from Denver. Hey, Denver. All right. I've been to Denver one time. Greetings hello from San Diego. I love San Diego. I'm not too far from San Diego. I'm actually in the Los Angeles area. So it's a little bright and early in the morning for me, but hopefully you guys all brought your favorite beverage, and I have my coffee here. So we'll get started right now. All right. Ooh, Bangalore, India. Nice. You know, there was a KubeCon in India a couple weeks ago. Let's see. Okay, we are gonna just jump right in. So if you've navigated to those either of the URLs, you should have been taken to this labs website here. This is where we host a bunch of different labs as it pertains to Azure Kubernetes Service. And if you're looking to just get started, we did a couple of these sessions back in May. But today we're going to head down over to the AI portion of the labs. And we're actually going to do this website, or excuse me, we're going to do this lab here. So go ahead and click on that, and it will bring up the build RAG applications with the Kaito RAGengine lab. And once you're in here, just click this link. I should say this button, right? To just scoot that menu to the side because we don't need it anymore. So we'll just kick it over to the side, and then we'll go ahead and get started. How many of you were online 2 weeks ago when we did the Terraform stuff? And I'll wait in the comments just to see. Let's see. Alessandro. Hey, Alessandro. Good morning. Yes. If you were here for the Terraform stuff a couple weeks ago, you might be happy or excited to know that we're still going to do more Terraform. Okay. And so what we're going to do here is basically, we're going to understand what this retrieval augmented generation pattern, like what that is, what the pipeline is, and what it involves. Then we're actually going to stand up an AKS cluster from scratch, install Kaito, and then we're going to deploy the RAG workloads. Okay, so you're going to need a few things for this workshop. Number one, you're going to need an Azure subscription, and you're going to need enough GPU quota, and I'll show you how to do that in just a second. You're also going to need the Azure CLI, and then you're going to need Terraform and Helm, because we're going to deploy the Kaito controllers into the cluster using Helm. And then, of course, kubectl, right? Because we're going to interact with the cluster, okay? JQ is highly recommended, only because we're dealing with a lot of the JSON data here. And so it's probably recommended to do that, okay? And so what I'm going to do here is I'm just going to kind of like flip back and forth, and we're going to get started here because this could kind of take a little while to do, okay? So the first thing we're going to do is we are going to set up the AKS cluster with Kaito, and we're actually going to clone the Kaito project, okay? Inside of the Kaito project is a Terraform folder where we store like a sample Terraform script that you can deploy to easily launch a brand new cluster with Terraform installed. Now, oops, that's not what I want to do. That's not what I want to do. I want to cd into my temp folder. I'm going to paste that stuff in there. It's going to say Kaito already exists because I've already cloned it, but I am in the Terraform directory. And inside my Terraform directory, you can see I have a couple of Terraform files, and I'll show that to you in just a second. But let's go ahead and kick this stuff off. So first thing you're going to need to do is, we did this last time around, and let me know if you guys can see this. I can bump this up just a little bit more. First thing you need to do is you need to export your Azure subscription ID into a variable called arm_subscription ID. So go ahead and do that. Actually, that won't work unless you're logged into the Azure CLI. So you have to log into the CLI. I'm already logged in, so I just ran that command. Okay. And then what we're going to do is we're going to do a Terraform init. So we're going to initialize all the different plugins that we're using. And I'll show you this in a second as we watch it build out. Rather than just watching it, I'll show you the Terraform. So a couple different plugins here. So we're using the Kubernetes plugin, Kubernetes plugin, the Helm plugin, right? And those are pretty cool things that we didn't show in the previous session, but that we're going to get to use today. And then, so what we'll do is I'll do a Terraform apply, and we'll go YOLO mode one more time. Actually, you know what? Before I do that, hold on. I want to show you this. Cat variables TF. Okay. A couple of variables that you should look out for. Number one is the location. Right now it's defaulting to I think in the repo it should be like Brazil South, I believe. I changed it to West US only because I had enough. I know I have enough quota over there in that region, so I changed this value here. So it's inside the variables.tf, and then you can update the default value here, and then node pool count just to keep costs a little bit low. I'm only using one single node pool because that's totally fine for the system node pool for this particular demo. And then the node pool VM size. So if you don't have enough quota, the Terraform will let you know. It'll fail and it'll tell you, hey, you don't have quota for this particular SKU. But I've gone and double checked that I have this particular SKU. And this is just for the node pool VM size. So with that, I will go ahead and kick it off. And do you remember this flag right here from the last time? We call it YOLO mode. We're just going to go ahead and auto approve it because typically you would have to confirm by typing yes, and it's going to kind of like go ahead and do the deploy. But in this case, I just want to kick it off, and yeah, we'll just let it go. Okay, so it's 15 to add, 0 to change, 0 to destroy. All right. So I think it's going off and doing its thing. So before we do that, let's see. We want to do run the deployment, and then after it's deployed, what we're going to do is we're going to do the AZ AKS get credentials command. This is going to allow us to connect to the AKS cluster and then start working with the AKS cluster using kubectl or Helm, right? And then here's a little bit of trickery. I shouldn't say trickery, but a little bit of bash command. So I'm basically doing a Terraform output and grabbing the resource group name, and also doing a Terraform output and grabbing the AKS name, and kind of like funneling that into the AZ AKS get credentials command here. Okay. So we're going to do that in just a second. Now let's go check on this. So this is all going. That's fine. Lovely. We will wait on that because it takes around, I want to take around 12 to 15 minutes. We'll see. And I have a backup deployment ready to go just in case this stuff takes a little too long because we only have 60 minutes here. And so I want to be able to get through the entire content with you all. Okay, so while we're waiting on that to deploy, let me give you a quick tour of the Terraform. So I have VS Code open here, and if you have the folder open as well, you can see inside of the Kaito project, there's a Terraform subdirectory here. Okay, let's give you a quick Terraform crash course here. So close this down. So remember, similar to last time around, you do have to provide your required providers and the specific versions for them. And so we're using Azure RM to deploy Azure resources. I'm using random to generate random numbers because sometimes, actually, I wouldn't say a lot. Quite a few of Azure resources require very unique names. So I'm just using a random provider just to generate a random number for me. I'm also using the Kubernetes provider and the Helm provider, okay? You can actually set up the Kubernetes and the Helm providers basically using the kube config that comes back in the AKS resource, right? And so here, this allows my Kubernetes provider to talk to my Kubernetes cluster once it's deployed. So I'm literally just reading from the kube config and passing in the host to the Kubernetes host, the username to the Kubernetes username, right? And so you can see that it's fairly straightforward. And let me just knock that down a little bit. And so we're doing the same thing for Kubernetes and for Helm, okay? So this allows both of these providers to talk to my AKS cluster. Generate a random integer, create a resource group, and there's nothing else in the file. Why? Because I have this stuff kind of split out into multiple files just for organization. Otherwise, this would be a really long Terraform script. So if I jump over to Kubernetes and then knock that down, you can see this doesn't do a whole lot. It just creates the AKS cluster, gives it a name using my random name. And let's go look at that. So this is local. So I'm using a local variable here. So all I'm doing is I'm calling my random name Kaito demo, and then I'm just appending the random integer to that, right? So couple of key tidbits here. When you want Kaito enabled on your AKS cluster, you need to enable the OIDC issuer. And you need that because you need to enable the workload identity feature on the AKS cluster, okay? And we have the default node pool sitting here. And remember, I just set this to a node pool count of 1, and then the node pool VM size is 1 as well, okay? All right, so from there, I have a AKS ACR pool. And remember, I think we did this in the previous session. We actually deployed a container registry, but in order for the cluster to talk to the container registry, it needs an Azure rollback, RBAC assignment. And so ACR pool is being added here. Okay, that's just the cluster. All the fun stuff happens over here in the Kaito TF. Before we jump into Kaito TF, let's take a look at how our deployment is going. Oh, wow. That was a lot quicker than I thought. Okay, so looks like my cluster is ready to go. AKS Kaito demo 66. All right. So what I can do now is I can actually go ahead and connect to the cluster. Okay, it is connected. And we're going to need a workspace. Now, if this is your first time hearing about Kaito, you probably don't know what a workspace is. I've done a couple of sessions in the past on the Reactor channel on Kaito and doing inference using a workspace. We'll just go ahead and deploy this, but I'll talk about it in a second because this takes a little bit of time to deploy as well. Let's see. I'm just going to refresh this because I thought I changed this. Hold on a second. Refresh, close this. Deploy sample workload. No. Deploy sample workspace. Okay. This is what I wanted. I actually updated this. So one thing to call out here is that the standard preset workspace for the 5.4 mini instruct model. Let me zoom this in. Oops. This requires a pretty big GPU. So it requires a NC24 ADS A100. Not a lot of folks have access to that, and it might be a little cost prohibitive, especially for a lab learning environment. So what I've done in this particular workshop is we can actually scope this down a little bit just for demo purposes and to make it more cost effective. And we can actually use a smaller GPU. So we can use a NC4, AST4. And so here we're just going to prioritize cost effectiveness over performance, right? So smaller GPU is going to be a little bit slower to respond, but you know what? We're all learning here, and this is totally fine for learning environments. So let's go ahead and kick this off because, like I said, this takes a little bit. So the workspace has been deployed. And we can actually just watch the workspace deploy. Let's drop this down just a little bit so we can see. Okay, there we go. So basically what I'm waiting for is resource ready to be true, inference ready to be true, and then workspace succeeded to be true. So this takes a little bit. While we wait on that, let's actually go and take a look at the the Kaito installation, like what we did with that Terraform script, because a lot of the stuff kind of happened auto magically. um, so when you deploy Kaito manually, now this is the open source installation of Kaito, you need a user assigned managed identity. And we're just calling it Kaito provisioner here. We're actually giving that managed identity contributor access to the cluster itself so that it can actually go provision GPU nodes, right? Because that's what Kaito is about. It's all about automating and orchestrating this stuff for you, and it can actually go and provision a GPU node for you. We also need a federated identity credential. This all goes into the whole workload identity bit. And I believe Joey did a session on workload identity in one of the sessions, I think in April or no. It was probably like early June timeframe, but he did one on workload identity. And so we're using that here. Okay. Here's the cool bits here. So Kaito requires two different controller installation. Well, I should say it doesn't really require GPU provisioner, but GPU provisioner is, I guess, the easy path here. Okay. GPU provisioner. So the Kaito engineering team, they actually host a GPU provisioner chart over here at this Azure GPU provisioner repo. And so basically what I'm doing is I'm passing in a variable for the latest version of this. And we're basically passing that into this Helm release provider. And within this Helm release provider, we can actually deploy the Helm chart, but we need a whole bunch of information to deploy that. We need things like the tenant ID, the subscription ID, the resource group name, where we want these GPUs to be deployed into, the AKS name, right? The actual client identity of our managed identity that we created up here, right? And that's actually all being passed in through what's known as a template file. So, and this is what the template file looks like, right? So if you've deployed with Helm before, you know that you can generate these template files and actually pass in your actual values. And then when you do the Helm install command, just send all the values with it, right? Rather than hard coding this stuff or taking care of creating the file on my own manually, I don't want to do that. What we've done here is basically said, Terraform, you know all these little bits of data, right? And so take these values, plug them into this thing called TMPL, right? It's a values template file, and create a real file from it, right? So you don't really see the real file because once the file is created and used, it kind of goes away. But you see these placeholders here. So this is kind of like the templating syntax. So what it does is that it actually swaps the parameter value with the actual value as it calls in. So that's just a little bit of understanding and knowledge for you all. The other controller that we need to install is the Kaito Workspace. And that's the thing that we just deployed to basically host our 5.4 mini instruct model. Okay, so same deal here. We're just using the Helm release when we're pointing to the Helm chart that is published at the Kaito repo. And so that's being, that controller has been deployed. And then here, the Kubernetes secret, not necessary for this particular lab, but this Kubernetes secret is actually used to hold the Azure Container Registry secret. This is if you wanted to do fine tuning with Kaito. And I'll talk about that in a little second, but Kaito does do fine tuning, right? And then here, this is what we're deploying. So the Kaito RAG engine, this is a third controller. And it's also, the Helm chart is also hosted on the Kaito repo. And so we've actually deployed that. Okay. Let's see. I think that's pretty much it in terms of like giving you a tour of the Terraform. Let's see how we are doing here. So we are very close to being deployed. So the resource is actually ready. So that GPU provisioner went out and grabbed us a NC4 T4 virtual machine node, and actually created and put that into a node pool for us. And now we're just waiting for some of the inference components to come online. So let's just go and let's go this way and head over to the Kaito docs. So if you navigate over to the, and I'm just going to click that. If you navigate over to the Kaito repo on GitHub, you'll see this URL over here. The Kaito team has fairly recently, I think this website has been around for a while, but they have a whole doc site. So if you are okay or comfortable just navigating around the source code and looking at some of the markdown files, that's fine. But if you need, if you like to look at something a little bit prettier in like a website form, Kaito does publish a website for this. Okay. And so this will tell you all the cool things that Kaito can do for you, right? And so what Kaito is basically aims to do is it aims to automate and operationalize a lot of the AI and ML workloads for you, all while using Kubernetes native constructs, right? And so the Kaito project is actually built using the very common pattern of custom resources, defining custom resource definitions, and then allowing Kubernetes to kind of like reconcile and do all that stuff for you, right? So all you need to do is you just need to know how to work with the Workspace custom resource, the RAGengine custom resource, and the Kaito operator just kind of like does all the stuff on the back end for you. So you don't really have to worry about all that, right? When it comes to RAGengine, RAGengine aims to streamline the retrieval augmented generation pipeline so that you can leverage external knowledge bases and incorporate that into your LLM based apps. I shouldn't even say LLM because LLM is large language models. Any language model apps, right? Any applications that you're building that talks to a language model, whether it's an LLM or SLM, doesn't really matter. It's going to kind of orchestrate all that for you, right? And so the key features of the RAG engine, and let me just take a look at here. So this is the retrieval augmented generation stuff. And so the key features of the RAG engine is to, number one, tackle the orchestration bit for you. That's like retrieval, taking the data out of the knowledge base and then passing it off to the LLM. The knowledge base is actually stored in a vector database, right? A vector database is a specialized database that kind of stores everything in like a numerical format. I mean, it's just a simple way to explain it. But all the data is in a numerical format. And once data is in that sort of format, you can start to build, or actually these vector databases can group things into clusters so that things are very, things that are very similar together will be held closer together and have a closer numerical value. And that's what a vector database essentially does. But in order to get that data into a vector database, you need to embed your text, right? And so you can use an embedding model. And I think it uses, so the model that's being used here is like a very small BGE small ENV 1.5 embedding model. It basically takes your text, turns them into tokens, which then can be stored in the vector database. So that's basically what that does for you. Okay. And do they note it here? They don't really note it here, but basically the default vector database that the Kaito RAG engine uses out of the box is what's known as this FAISS database. So this is actually, it's an in-memory vector database built by the friends at Facebook. And it's a pretty efficient way of doing it. The vector, the embedding models, you can actually point to any embedding model. This is just one of the defaults that they go with. And you can choose to use a different embedding model if you want. Right now, the vector database is set to FAISS, but in the future, you can actually look to using a remote vector database or any other vector database of your choice. But as of right now, it's just all in memory. Okay. Let's see. How is our, oops, wrong way. How is our deployment? It is still going. So like I said, if this takes a little while, we can do something else and we can play with it there. But it's only been 4 minutes, so I'll give it a little bit more time. We just got to be patient with this stuff. Okay. So I talked about the embedding model to take your data, turn them into numerical formats, and then store them into the vector database. It also needs to know what this inference service is. Okay. And so the inference service, this is pretty cool. It can be actually any open AI API compatible inference service. Okay. What that means is if you have a Kaito workspace deployed in your cluster, you can keep all that communication inside of your cluster. So the RAG engine is there and the workspace is there. All the communication just stays in the cluster. That's great. If you want to use, let's say, OpenAI's public inference service, like let's say you have an OpenAI API key that you want to use, you can do that as well. Save you a little bit of cost on the GPU, but that means your RAG engine will actually query the vector database and then go out and talk to the Azure OpenAI endpoint, which, depending on your requirements, totally up to you. Okay. So that's pretty much it, I think. Let's talk a little bit about the inference for the folks that don't know what the inference does or what the workspace does. So basically, Kaito, they have a set of, I would say, presets. So if I go click over here, presets. So for all of the super popular open source models that are out on Hugging Face or whatever, the Kaito engineering team actually have presets that you can actually take advantage of. What they do with these presets is they actually containerize the model and the model weights into a container that they store over in the Microsoft Container Registry. So that's already taken care of for you. They've done a little bit of vetting to make sure to find out which GPU works best with this particular model. And so that's kind of like packaged into the preset workspace. And then when you deploy the workspace, the Kaito workspace controller will look at that manifest and will be like, okay, let me go do a deployment. Let me deploy the pod, obviously. The pod will go and get that container with the model, and then let me expose it as a service so that the endpoint is just ready to go. And so it's just OpenAI API compatible. And that's pretty much it. And you can see here that there's some pretty popular open source models. I did see I think it's a pending pull request or a pending issue, the brand new GPT OSS model. So they will be coming into Kaito very, very soon, I would imagine. I was just kind of poking around through the repo a little bit earlier. So that's coming. And in terms of like deploying the workspace, I mean, we did that here. You can see it's like super simple. it's only like 12 lines of YAML. And 12 lines of YAML gets you a full-blown AI inferencing endpoint, which is pretty remarkable. So I do enjoy, or I do definitely appreciate the simplicity of it all. Once this thing comes online, let's go check it out. Bum 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 bum. Haha. Okay, so we are in business. Everything that we wanted true is now true. So the resource is ready, the inference is ready, workspace is ready. Cool. Let's deploy a sample workload. So I'm just going to deploy the AKS store demo project. You may have seen this often. Okay. And I am going to wait for, I'm just going to wait for the front end to come online. There we go. So then I will take this IP, copy it, and go this way and drop that in there. There we go. So here is the demo scenario here, right? Using the RAG engine, and let me do this before I start to get a little carried away here. I'm just gonna do this just for time's sake. I'm just gonna speed ahead, do this, bum, 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 go this way. I'm gonna deploy the RAG engine, and then I'll talk a little bit about it, so we don't have to wait on it. Here's the demo scenario that we have. Okay, let's say we are building, or let's say we are maintainers of an e-commerce store, and naturally all the applications that are out there nowadays, there's a chat component associated with it. The chat component is for your end users to get a more personalized experience, be able to talk with an intelligent assistant and help you, in this case, shop. Now, let's say, for example, I don't have a chatbot here yet, but we're just kind of like thinking through this and building out the foundations of a chatbot. Let's say a user comes to our e-commerce store and wants to, I don't know, say, is looking for a bed for their cat, right? And if they chat with this chatbot, you would want the chatbot to limit its answers to just the products that they sell, right? You don't want it to talk about a cat bed that's sold at, I don't know, PetSmart or, whatever big pet retailer is out there, right? You want it to kind of like give answers based on real products in your store. And so that's what we're going to do here is we're going to, before we build any chatbot, we want to make sure that our language model is grounded in our store data. And then from there, we can start to build out the UI. And so we got to get the fundamentals or the foundation right before we start building out the other components of it. And so that's what we're doing here. No, not this one, this one. Okay. So we've browsed to the website. We can see what the website looks like. And I gave you the scenario that we want to deploy. And we want to deploy this RAG engine, which we've done, right? And so talked about the knowledge base, the vector database, and the embedding model. And so we've deployed this little YAML manifest. And the YAML manifest is, again, it's pretty short, right? One thing to call out here for this particular lab, I think in the repo, the sample SKU or the recommended SKU is like a T4. So it's a GPU SKU. But for the purposes of this workshop, again, I'm focusing on cost optimization for you all. I want to keep the cost as low as possible for this demo. And so I'm actually using not a GPU SKU. This is just a regular CPU based SKU. So there is no GPU here. Why? Well, because the embedding models, they're typically small. They don't require a lot of like GPU. I mean, they're not GPU intensive things, right? And so You can try to get away with the CPU skew. I've actually got away. I've tested this, and it works totally fine. But depending on the model that you're using, you might want to revisit your skew choice. Okay. And then the workspace that we just deployed, we're going to actually use that. So we're going to funnel all of the queries to that workspace. And let's just go see what this workspace endpoint looks like. So let's do this. So this workspace 5.4 mini instruct, we actually want to test it. Boom, 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 boom. Let's clear that. Okay, get service. Okay, so we have this service because our workspace is online. We can actually do a kubectl port forward. We can do a port forward to the service because there's no public IP on it by default. So we are port forwarding. Hold on. FG. Nope. No. Let's try this again. Oh man, I need to go kill a port, or I can just map it to some other port. 8081. Let's do that. Okay. So we are forwarding on 8081. And I am, why does it look like that? Hold on a second. That is not what I want. Clear. There we go. That looks better. So what I'm going to do is I'm actually going to query this endpoint. And remember, this is just a workspace that I port forwarded on 8081. And I'm going to ask it, hey, I need a new bed for my cat. And it's actually going to query the language model that's running inside of the workspace. And it should give me an answer that just doesn't make sense for my particular use case. Okay. And so it's like, yeah, of course I can help you. And it's like not really guiding. So it's actually telling me to go to Petco cat bed or go search for Amazon Basics cat bed, which, I mean, for a general purpose AI, it's totally fine. But if my users on my e-commerce store site, I want them to purchase my cat bed, right? And so that's the situation that we have here. So if I just bring this forward again, I'm going to stop the port forwarding there. Now, what do I want to do? I want to index my product data. Okay. Because remember, your external knowledge base needs to be put into the vector database. And in order to do that, you're going to need to index the data. And when you index the data, all you need to do is just basically format whatever external data that you have into a JSON format that this RAG engine will understand. And so you just give it a name. In this case, I'm just calling it store index. And then you're passing in the documents, and it's just going to be an array. So the text could be, in my case, I'm just going to put like the product data, and then I can put some additional metadata in there. This could be anything, anything you want, anything you want to be relevant for that conversation, right? And so what I can do here is I'll go ahead and let's clear the screen there. I'll go ahead and grab the store IP, and then I will go make a call to the store. And I notice my terminal does this a lot. It puts these slashes in for me, which I don't want. So I'm just going to run that command. Okay, so I basically ran, if you look at the top bar here, there, doesn't really capture all of it, but I basically just ran a curl command to my products API endpoint. And you can see that I'm getting all my product data that I need. I'm actually going to use this endpoint to build my my JSON data for indexing. Okay, so let's just go ahead and clear that. And I'm going to transform my product data. Now, you could have your own kind of data pipelines that transforms this stuff for you. I have a small set of data. It's only 10 products in this sample store. And so I can literally just use bash to do this. So I don't need to go fancy at all. This is just to kind of show you what the process is in terms of indexing, not necessarily building the data source. Okay. So what this, I guess, semi-complex bash command does, it basically, actually it's a JQ command. So what I'm going to do is I'm going to grab all the products that we just saw, and then I'm going to transform some of that data. My text is going to be the product description. I'm also going to include the price, and the author is going to be the Contoso Pet Supply Store. Category, I'm going to set the category in there, and I'm going to make sure this. I'm going to make sure that I pass in the URL for the product into the index data, so that when it responds, it's like, oh yeah, we have this cat bag. Go to this URL and then go check it out. So that's basically what we're going to do here, right? So if I if I take a look at the store products JSON document that we're intending to index, you can see here that here's the text. So this is basically what the search is going to be done on. And then here's all the metadata that comes back from it, right? So, and this is exactly what I want. I want stuff like this. I want it to answer with a concrete URL that, no, I don't want an update. It asked me to do an update on live stream. I think we need some sort of AI to kind of check for that. But basically, going back to my point is, I want my language model to respond, give a URL, and the user goes there and makes the purchase, right? So that's what it is. That's what I'm doing. So what we're going to do is we are going to port forward the RAG engine. So let's do get RAG engine. True. Love it. Okay. So we're going to port forward, but 8080 is used by some other process that I kept running. So I'm just going to change it to 8081. And I'm going to run this index command. So clear the screen. Here's the index. I need to change my port. 8081. So I'm basically just doing a post to my RAG engine on the /index endpoint. And I'm basically passing in the JSON file that I just created. And then I wanted to kind of return all that stuff back to me. And so you can see here that I have document IDs, and here's the text. So this is basically all the values that I wanted to index. So, so now if I go and I query my indexes, oops, wrong port. You can see here that I have my store index here ready to go. If I wanted to actually double check to see what's in the index, you can actually do a get command on the indexes endpoint, pass in the name of your index, and then say, give me all the documents. So give me all the documents, and this is all good. And so what's going to happen now is this, and I'll just show you a quick little Excalibur draw. So what initially happened was the user asked a question to the workspace, just the workspace. The workspace hosts just a general language model, knows nothing about my products, and it returned an answer, the best answer that I can possibly think of, which included things that aren't related to my store. What's gonna happen now is, and this is supposed to be me with the hat. I index product data. Okay. The user asks a question, but the user is not asking the workspace anymore. The user is making a question to the RAG engine, but the user doesn't know that because it's all in the app, right? But the question is actually being sent to the RAG engine. The relevant documents inside of the vector database are actually retrieved based on similarities, right? In the query that they submitted. And it's going to go and retrieve the most relevant documents, send that along with the user's question to the workspace. And remember, it could be Workspace, it could be OpenAI, whatever. But in our case, it's the workspace. The answer, so now the workspace or the model has a question, it has all the relevant documents, and it gives a grounded response. And that grounded response is sent back to the user. Okay. So let's go and test that. I am going to go down here. And remember, we are now querying the RAG engine, right? So we're not querying the V1 chat completion OpenAI API anymore. We're just going straight to query. And remember, the user doesn't know this is happening because this is actually coded. This should be coded into the UI of your application. And so now I'm going to say, I need a new cat bed. Can you please help me? Okay. So let's do that. Bum, 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 bum. And I have to remember to change my port. Okay. This could be fast or it could be slow. Remember, I'm prioritizing cost over performance. So we'll see. If you have a bigger GPU, obviously it's a little bit quicker. So let's see. It'll eventually come back. While we're waiting on that, let's see. Just looking through the chat here. If you have any questions on this stuff, just feel free to put them in the chat here. Great diagram. Awesome, Aaron. Hey, Aaron. That diagram kind of helped me visualize what's really happening with the RAG engine and just RAG pipelines in general. So we'll wait on that, and it should come back with a decent answer. This is where we wait. But you know what? We're doing pretty good on time. Aha, here we go. So it comes back, and there's a lot of stuff in here. Let's just scroll up and see. I'm already seeing some good stuff. So here's the response. I recommend the Seashell Snuggle Bed from Contoso Pet Supply. Love it. It's a plush bed shaped like a seashell, providing comfort and relaxation for cats and small dogs. It's priced at $19.99 and can be found at this URL. So let's see. I just want to make sure this is true. You're not making stuff up, right? Boom. Hey, look at that. That's perfect. That's exactly what I want. Okay. So it gave me a really long-winded answer. I mean, you can obviously tune this a little bit more just with the prompt parameters, right? So here, max tokens 2048. I mean, you can kind of shrink this down just a little bit in the LLM params and give you a little more short and concise answer. This is what I want. I like this answer. It's just a little too long for me. So we blow past all that text. And then you can see source nodes, right? So these are the documents, the relevant documents that were sent up to the language model for additional context, right? And so these are weighted answers, and it looks like score. I wonder why I think I need to look into this. Like, why you would think that the seashell snuggle bed is the most relevant and would have a higher score. But then I'm seeing here that these have higher scores, but these are less relevant. So interesting to know. Oh wait, I think the score goes higher. So yeah, I guess the lower the score, the better. If you guys know, let me know. But that's what it looks like. But in any case, this was the most relevant document for the query, and it returned the right stuff. So that's good. Going back to the lab, I think we're pretty much near the end of the lab. And so that's basically it. You can see like building and deploying these RAG pipelines into your Kubernetes cluster was literally as easy as deploying. Where is that YAML? Where is that YAML? It's as easy as deploying this little YAML manifest. And we're talking like, what is it, like 13, 14, 15 lines of YAML. So it's super easy, especially for folks or organizations that are just getting started with building AI enabled applications, and you want this data to be grounded in real data, your organizational data. So definitely worth a look and worth trying out, because otherwise you'd have to build up all this stuff from scratch, right? So and the orchestration bit, I didn't mention it, but it's actually using Llama Index. So as part of your RAG engine deployment is a Python application built using Llama Index. And so it does all of the orchestration, retrieving from the vector database and sending over to your language model. So it does all that, right? So yeah, I think at the end of it all, hopefully your end-to-end experience is a good with this particular lab. If you have any questions or anything comes up along the way, feel free. My DMs are always open on the socials, whether it's X. I'm on LinkedIn a lot, so you can always find me on LinkedIn as well. So yeah, so we deployed the infrastructure using Terraform, piece of cake. We deployed the 5.4 mini instruct model using the Kaito Workspace, piece of cake again. We actually index real data from our sample or demo e-commerce store and put them into the vector database using the index endpoint of the query of the RAG engine. Easy again. Now, in real life, in your scenario, it may not be that easy. You probably have to look into like how you want to model or mold your data. Mine was a very simple use case, but you may want to look into like how you want to mold that data. And then querying is just querying the RAG engine endpoint, and then letting the RAG engine do all the hard work of fetching the most relevant documents, right? So what's next? I would say this. If you want to dig into Kaito a little bit more, feel free to head over to this lab here. We don't have a session for it, but head over to this lab here. And this is all about working with the Kaito workspace, but this is a little bit different. Okay. Kaito, you can actually install using the open source tooling, which is what we did with the Terraform. But did you know that Kaito has a managed experience on AKS, and AKS can actually manage the deployment and all the good stuff around Kaito. So it's literally as easy as toggling. If you're using Azure CLI to deploy your cluster, you can, I think it's a flag. I think it's like enable AI toolchain operator or something like that. I can't remember the name. But you just toggle it on and AKS will take care of all the installation for you. So you don't have to worry about doing the Helm installs and all that stuff. And then the cool part about this particular deployment is that it's using VS Code to install the add-on, and then it uses Headlamp, which is an open source project that allows you to basically work with Kaito if you like a GUI experience. I personally like being in the terminal, but if you prefer more of a GUI based experience, this is a pretty cool way to get started. Okay. With that, let me see. I'm just going to see if there are any last questions. So let's see. Since the LLM from Raghav, since the LLM is loaded into the workspace, there is no token charges. 100% correct. And this is why a lot of folks like to host their own language models inside of Kubernetes, actually just host their own language models. There could be a variety of different reasons. Number one is a token charge if you're using like a SaaS solution or managed solution. Number two reason of why a lot of folks kind of like start shifting towards hosting, and especially Kaito, it's due to data sovereignty restrictions. You may have compliances that you must adhere to. Data security, all that stuff stays in the cluster. So yeah, very huge reasons for looking into deploying language models and hosting them yourselves. Okay. Let's see. Question or comment from Andrew. As usual with Microsoft Learn, why to use it, I don't know. I think I just answered the question. If you need to host a language model and not worry about going to an external endpoint, or you want to keep everything confined into your own network or even in your own cluster, using a solution like Kaito will definitely take care of that for you. How does Kaito compare with projects like LLMD? Similar. Kaito actually hosts the model inside of a VLLM server. So it uses that as the engine for running inference on the model. LLMD, if I understand correctly, is just a different way of hosting models. And LLMD very much focuses on, like, I believe, like partitioning or distributing the model inferencing. And so very similar. And stay tuned to the AKS blog or any of our community facing documentation. We might be publishing an article on that very soon. So keep your eyes and ears peeled for that. Okay. Let's see. One last question, because I know we are like 3 minutes overdue. Probably out of scope here, but what would be your approach using guardrails with the solution, aka protect from jailbreaks? Guardrails, jailbreaks. So that kind of sounds like more so like protecting the LLM from kind of like deviating or doing things that it's not supposed to do. So in that case, number one, like if we're just talking just general guardrails, like just confining, a Kaito workspace is stored in the cluster, so all the communication happens in the cluster. So as a cluster operator, it's up to you on whether or not you want to expose these endpoints, right? Number two, in terms of like jailbreaking and giving bad instructions, I think that really boils down to like the query that you send over to the LLM, right? Make sure you're sanitizing the query itself a little bit, making sure that there are no, I would say, like nefarious instructions that go into the LLM, right? So it's a little bit around that. I know that's not a great answer. Like there's no like sure shot, like there's no switch that we can flag on to say that, nope, this LLM is not going to be able to be jailbroken. But unfortunately, security is like a multifaceted thing. You have to like attack it from all angles because the attacker's coming at you at all angles. So that's kind of like my short answer to that. With that, I do want to end on this note. This is the last session that we have on the schedule for AKS Labs on the Microsoft Reactor. There are some folks that reached out. They're a little bummed out about it. If these sessions were helpful to you, scan that QR code on your mobile phone and answer 4 question surveys, super simple questions. Just let us know, give us feedback. We'll take that into consideration, and we might come back with the season 2 and continue to do this stuff. It's been fun for me. I hope it's been fun for you. And yeah, let us know how we're doing via this little feedback form. And I will be around. I'm not going anywhere. Hit me up, drop me a message on LinkedIn or whatever. I'll be happy to answer any questions that you have. So thank you for spending the time with me and all the other great speakers that we've had on this series. And I guess that will be it for now. And we'll see you next time. Bye.